All right, here's part 2 of the lab. This is the basic setup right here. It's deliberately a little bit off because I wanted to emphasize a couple things here. One, we have basically the 4 scales that are hanging freely here, and the meter stick is hanging on them. I have some paper clips here and here in order to be able to have to put the meter stick on something. Now notice one, that it's not parallel to the ground, so that's one thing that needs to be corrected. Another thing is that this needs to be at the 10 centimeter mark and this needs to be at the 90 centimeter mark. And so first let's get this at the 90 centimeter mark. And so I need to adjust it. So one, it was at an angle, which is one problem. And two, it's not, I lift it up so let the paper clip sort of move freely. And I put it down. It's still not at the 90 centimeter mark, so I have to actually move the base. And it's still a little bit off. So the more time and care I can put in at this point, the better it is. This one should be already at the 10 centimeter mark because I had that one set up before I started the video. Now the other one is the fact that it's not level, so I need to adjust that. Now I adjust that by adjusting this right here. And so since this side is high, I need to lower it. And I've got the chalkboard right here is sort of a level. Let me see if I can step out of the way and make sure it's all the way across. Get some of these things out of the way. And that's looking pretty even right there, assuming that the blackboard was put on properly. I tighten it, step back, make sure it's very, very close. All right. Now I can also bring the level over here and check that, as well as there's some apps on some phones, not mine, but some phones. So now I have it set up here. I have 3 forces acting on this right now. I have the weight of the meter stick acting down at the 48.7 centimeter mark. I have a force acting here up, and I have a force acting here up. Now the total force acting up should be equal to the total force acting down. That's chapter 2 kind of equilibrium, that's linear equilibrium, and it's static equilibrium more specifically. The other bit is, since we're now dealing with chapter 8, we have to bring torque into it. And so I want to figure out I want to make sure that the sum of the torques is also 0. Now, it's a real lab, and so the results will be iffy. But the basic process we're going to go through is going to be important here. Now, I'm going to go through one example in the next video. I do want to bring up the fact that what's my axis of rotation? Because torque is about an axis of rotation. But it's not moving at all. Is there a natural point where this thing moves? Well, the deal is that when you're dealing with an axis of rotation for something that's not moving, you can pick any point. So there are convenient points. If I pick an axis of rotation, whoa, and that's how you mess up an experiment. If I pick an axis of rotation here where this force is acting, then that basically this exerts no torque, and I've eliminated some of the math. If I pick the center of mass of the meter stick, that eliminates something. If I pick here, it eliminates something. I could also pick the end point here, in which case I have 3 torques acting about this point right here. I have the torque from here, torque from the meter stick, and a torque from this force right here. So where I pick it really matters. And actually, I could pick wherever you're sitting right now as you're watching this video. That could also be, the math becomes a real mess, and so that's generally why we don't pick that. You pick a point which makes life convenient, or what's specified in the instructions. So the next video will actually set up one of the situations, and then on the last video we'll actually crank through some math and see what happens.